Hi everyone, I hope you're okay, and I really hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling a question on Doppler effect, and please do expect a total number of 11 questions whereby I'm tackling past exam question papers guys, né? And each and every question will have its own video, so you can just stay tuned guys and wait for more videos. We are told that the siren of a stationary ambulance emits sound waves at a frequency of 850 hertz. Firstly, the first thing we need to know that guys is that our source is stationary. Are you together? The ambulance is stationary, which simply means that the velocity of our source is 0 meters per second. Are you together? And then we are also given the frequency of the listener. The frequency of the listener, not of the listener rather, the frequency of our source, which is the ambulance, that's 850 hertz. Are you together? Frequency of the source is 850 hertz. So since guys our source is stationary, remember that guys our formula for calculating in Doppler effect simply says we have plus and minus velocity of the source, v plus and minus velocity of the source, that's velocity of the listener, man, and then at the bottom is velocity of the source, right? Multiplied by frequency of the source. Since guys our source is stationary, it simply means that the velocity of the source is equals to 0. I get. So I now know that my denominator, I know that FL will be equals, the denominator will be only V because Vs is equals to 0, right? Since the source is stationary. This is multiplied by the frequency of the source. And then that's V, frequency of the source. I'm writing this like this guys because there's a difference whenever the listener is moving away and when the listener is moving towards the source. Are we together? So if the listener is moving away from the source, it simply means that since we have two signs over there, we have to choose one of the two signs. Since the listener is moving away from the source, we will choose the negative sign. Are you together? But over here, the listener is moving towards the source. Are you together? Yes, you still have our V. Let me just write the V in red just to show that there's nothing new. Yes, you still have our V, right? We still have our V for the velocity of sound in air. Now, since the listener is moving towards the source, it simply means that I must choose a positive there. A positive. It will be a negative at the numerator when my listener is moving away from the source, and it will be a positive when my listener is moving towards the source. Okay. Now let's continue reading. An observer traveling in a car at a constant speed in a straight line begins measuring the frequency of the sound waves emitted by the siren when he is at a distance x from the ambulance. The observer continues measuring the frequency as he approaches, passes, and moves away from the ambulance. Okay. The results obtained are shown in the graph below. Please note that guys, these results are showing the frequency of the observer. Are you together? And please note that if the frequency of the observer is greater than that of the source, it simply means that the observer is moving towards the source. Are you together? And if the frequency of the observer is lesser than that of the source, it simply means that the observer is moving away from the source. Are you together? So over here, we have a greater frequency compared to that of the source. It simply means that over there, the listener or the observer was moving towards the stationary source. Are you together? Why am I saying that? Because the frequency detected is 900 hertz, but remember that the frequency of our source, it was 850. So if the frequency detected is greater than that of the source, that means our listener is moving away. Our listener is moving towards, excuse me guys, no? Our listener is moving towards the source. And then over here, we have 800 hertz, which is less than 850 hertz from the source. Now it simply means that our listener is moving away from the source. Why? Because the listener is detecting a smaller frequency. Our listener is detecting a smaller frequency. Okay. And then we are being asked that the observed frequency suddenly changes at t is equal to 6 seconds. Give a reason for the sudden change in the observed frequency. At t is equal to 6 seconds, that's when the listener or the observer is moving away from the source, and hence the listener or the observer will detect a frequency which is lesser than that of the source. Okay, and then 6.2, we are being asked to calculate the speed of the car. Yeah, we were spoiled of the information over there, né? If you want to use the information whereby the listener is moving towards the source, you can do that. If you want to use the information whereby the listener is moving away from the source, you can use that, né? Okay, let me write down the information so that it will be easy for you. When the listener is moving towards the source, né? The frequency of the listener is equals to 900 hertz. The frequency of the source, it doesn't change, that's 850 hertz. And then the velocity of the source is 0 meters per second. Are you together? And then the velocity of the listener, that's what we are looking for. The speed of sound in a medium, it was given to us as 340 meters per second. Are you together? This thing happens whenever our listener is moving towards a stationary source, right? Now it happens that the listener moves away from a stationary source. We have FL, frequency of the listener has to be lower than that of the source, guys, né? That's 800 hertz. And then frequency of the source, that's 850 hertz. Velocity of the source, 0 meters per second. The source is stationary. And then the speed of the listener, that's what we are looking for. The speed of sound doesn't change. That's 340 meters per second. Are you together? You have one unknown in both informations, guys. You can use either one of the information to calculate. Remember that, guys, whenever the listener is moving towards the source, we have a plus at the top. Whenever the listener is moving away from the source, we have a minus at the top. Use any of these equations with their correct information, you'll find the correct answer. Let's choose to use the towards. Né? For towards, we'll simply say FL is equals to V plus VL all over V multiplied by the frequency of the source. The examiner, guys, will mark you correct if you do this, né? And even if, guys, you write the original equation from your formula sheet, you will be marked correct. It says FL is equals to V plus or minus VL, and then V plus or minus VS all over FS. You will be marked correct. Are you together? Okay, now let's substitute. This will be 900 if and only if the listener is moving towards. And when the listener is moving towards, I'll simply have 340 plus VL all over 340 all multiplied by 850, which is the frequency of the source. Over here, guys, physics is done. The rest is just mathematical gymnastics, né? And hence the memo wouldn't mark your mathematical gymnastics. They'll mark the final answer that says VL is equals to something, né? But it's fine. I'm solving for, I want to solve for the velocity of the listener. So, which simply means I must just isolate this guy. Are you together? But before I do that, I need to remove anything which is subtracted, added, multiplied, or divided, né? The first thing I will remove is the 850, which is multiplying. I'll just divide both sides by 850. I'll simply have 900 all over 850 is equals to 340 plus velocity of the listener all over 340. Are you together? Okay, let me continue on the other side. I'll have 900 all over 850 multiplied by 340 is equals to 340 plus VL. I wanted to eliminate the 340 over there, so I multiplied both sides by 340. And then when I bring this 340 on the other side, I'll simply have 900 all over 850 times 340 minus 340 is equal to the velocity of the listener. Therefore, the velocity of the listener, 900 divided by 850 times 340 minus 340, this is equal to 20 meters per second. So the speed of the car is simply 20 meters per second. Okay, and then now they want us to calculate the distance between the car and the ambulance when the observer begins measuring. So the distance is just simple, guys, né? This part over here, this part over there, guys, represent the time when the observer is recording over there, né, guys, is measuring rather the frequency. Are you together? So the distance is simply speed multiplied by time. Are you together? I cannot use acceleration. Why? Because our observer is traveling at a constant speed, which simply means our acceleration is 0. So distance is just speed multiplied by time. So the speed rather is 20 multiplied by 6 seconds, and this is equals to 120 meters. 120 meters. That's how, guys, we're supposed to tackle this question over there. I really hope the video helped you. Just stay tuned, guys, and wait for more videos. Bye.